Hi everyone, this is Pawan Aditya. We have decided to talk about the topic data warehousing and ETL. Introduction to data warehousing and ETL. What is data warehousing? Uh, as organization generate massive amounts of data daily, data warehousing and ETL are critical in ensuring that the data is properly collected and processed and stored to the drive with meaningful insights and decision making power. In this presentation, we will explain the concept of data warehousing and the ETL, their significance in enterprise and environment, and the demonstrate how to build a basic ETL pipeline. So the overall flow of ETL warehousing, you can see in this image. So the data source come from various sources for the business, and we perform the ETL, which we'll be discussing in further. And then we store the process data in data warehouses, and we use this data for visualization, reporting, and business intelligence. Moving to the next slide. What is ETL? ETL stands for uh, extract, transform, load. This is a process essential for preparing data for analysis. It ensures the data from various systems is collected, cleaned, and formatted into a consistent structure before loading into a data warehouse. Let's break down the ETL process. Extract. The extract in this phase, the data is gathered from various sources like databases, spreadsheets, API, and logs. This step ensures that all relevant raw data is collected in its original form. Example, extracting sales data from an e-commerce platform. Coming to the next step, transform. The extracted data is cleaned and processed to make it suitable for analysis. This includes removing duplicates and null values, normalizing formats, deriving new metrics. So in the coming to the load phase, the transformed data is loaded into the target storage system, typically a data warehouse where it is ready for querying and reporting. The ETL process ensures the data is consistent, reliable, and useful, enabling business to drive actionable insights. Moving to the next slide. Why ETL and data warehousing are important. Uh, uh, Warehousing are the foundational modern to the data-driven enterprises. Here is why. Uh, Enhanced data accessibility. Centralized storage of data warehouse ensures that the data from multiple sources is accessible in one place, eliminating silos. With well-designed ETL processes, data becomes consistent and ready for the analysis. Powering business intelligence. Business intelligence tools like Tableau and Power BI rely on data warehouse for dashboards and reporting. For examples, a sales team can view a performance dashboard updated in a near real time due to a effective ETL pipeline. And then forecasting and trends analysis. With historic data stored in a data warehouse, enterprises can identify trends and make data-driven forecasts. Example, predicting customer purchase pattern during the holiday season. Supporting data-driven decisions. ETL ensures high-quality, clean data, which is critical for accurate analysis. Executives can make informed decisions based on the metrics derived from a data warehouse. Scalability and future proofing. Cloud-based warehouses like AWS Redshift, Snowflake allow business to scale their data storage and analytics needs as they grow. So these are various important uh, use cases of ETL. The further slides will be explained by my group mate.
So I will discuss in detail about the ETL now. The ETL process stands for extract, transform, and load. It's a crucial framework for managing data in organizations, helping transform raw scattered data into a structured format that is ready for analysis. Think of it as a bridge. It connects the raw data from various sources to actionable insights that a business can use for decision making. ETL is behind the scenes in almost every industry. Finance uses it for risk analysis, retail for inventory tracking, and healthcare for patient data management. The process has three main steps. First, we extract data from multiple sources like databases, APIs, or logs. Next, we transform the raw data. This involves cleaning, standardizing, and enriching it to make it suitable. Finally, we load the process data into a target system, often a data warehouse like Snowflake. This pipeline is the backbone of any data driven enterprise, ensuring that data is accurate, consistent, and ready for analysis. The first step, extract, is about gathering raw data from various sources. Organizations often deal with data in diverse formats, such as relational databases like MySQL or Oracle, where structured data resides. Flat files, such as CSVs, would store semi structured data. APIs, which provide access to dynamic data like real time weather updates or social media analysis. For example, if we are managing an e commerce platform, we might extract transaction records from a database, website behavior logs from flat files, and market campaign metrics from APIs like Google Ads. Another key factor is the frequency of extraction. Real time data, such as livestock prices, needs to be extracted continuously, whereas historical data can be pulled periodically. The main goal of this step is to gather all the data we need while maintaining efficiency and accuracy. After extraction, we move on to the transform stage where the real work happens. Raw data is often messy, inconsistent, and not ready for use. The transform step ensures that this data is cleaned, enriched, and structured. Here are some transformations: data cleaning, removing duplicates, handling missing or null values, and standardizing formats. For example, converting all data into a single format like year, month, and date. Data aggregation, summarizing data for better analysis. For example, calculating monthly revenue from daily sales figures. Data enrichment, adding additional context to the data. For example, combining sales data with demographic data to understand customer preferences better. Finally, the transformed data is ready to be loaded into a target system. The most common destinations are data warehouses like Snowflake and Google BigQuery. These platforms are scalable and allow organizations to perform advanced analytics. There are two primary loading strategies: full load. This involves reloading the entire dataset into the warehouse. This is useful during initial setups or major updates. Incremental load. This only adds or updates the data that has changed since the last load, making it much faster and more efficient. For instance, a retail company might use an incremental load to update its daily sales records, ensuring the warehouse always has the latest data. An important aspect of this step is maintaining data integrity. Errors during loading, such as missing records, can lead to faulty analysis. By carefully designing the load process, we ensure that the warehouses remain the single source of the organization. Now, I will hand over to my teammate.
Thank you. So let's see how the process of ETL pipeline creation is done. So we're going to walk through the process of building a basic ETL pipeline, which is a fundamental concept in data engineering. Our use case for this demonstration will be loading sales data into a database for analytics. So what exactly is ETL? ETL stands for extract, transform, and load. It is a process widely used in data integration to gather data from different sources, clean and transform it, and finally load it into a target database or a data warehouse where it can be used for insights and decision making. This pipeline process is crucial for any data-driven organization because raw data in its original form is often messy, inconsistent, and incomplete. ETL helps us take that raw data, clean it up, and make it ready for meaningful analysis. In today's demonstration, we'll be using Python and SQLite uh, to showcase how to build this pipeline. The tools we use are beginner friendly but powerful enough to handle professional tasks. So let's get started. Our first step in the ETL pipeline is extract. This step is all about gathering data from multiple sources. In our case, the source is a CSV file that contains sales data. The sales data includes several columns such as order ID, product, quantity sold, and unit price. CSV files are a common format for raw data because they're easy to work with and widely supported by tools and platforms. To extract this data, we'll use Python's Pandas library. Pandas is an incredibly powerful library for data manipulation and analysis. It makes reading and working with tabular data such as CSV files quick and intuitive. Here we're using pd.read CSV function to read the file into Pandas data frame. Think of a data frame as an Excel spreadsheet inside your Python script, rows and columns that you can easily manipulate programmatically. After running this code, print command will give us a preview of first few rows of our data. This is a great way to confirm that the data has been successfully loaded and to get an initial sense of its structure. Now the next step is to transform. Now that we extracted the data, it's time to transform, where we clean and prepare data for analysis. Transformation is crucial because raw data often contains issues such as missing values, duplicate records, or inconsistencies that need to be addressed. In our case, we're going to do three things. First one is to remove the null values to ensure our data doesn't have any incomplete records. The second thing is eliminate duplicate records to maintain data integrity. And the final step is to add a calculated column called total sales, which is derived by multiplying the quantity sold by the unit price. Here we are using drop any method to remove any rows. Similarly, drop duplicates helps us get rid of repeated records. And this final calculation of total sales gives us multiplication of two existing columns, which is quantity sold and unit price. This new column provides a single metric that summarizes the revenue for each sale, which is an essential metric for sales analytics. And the final step is load. Here, with our data clean and transformed, this is where we take the process data and load it into a database. Databases are essential for storing, managing, and querying data efficiently. For this demonstration, we're using SQLite, which is lightweight serverless database that's perfect for local use cases or small scale projects. However, in real world scenarios, this step might involve loading data into cloud-based data warehouses like Amazon Redshift, Google BigQuery, or Snowflake. Let's see how we can use this in Python to load data into an SQLite database. In this snippet, we first establish a connection to SQLite database. If the database doesn't already exist, SQLite will create it for us. Next, we use toSQL method from pandas to write our data frame to a table named sales. The if exists replace argument ensures that if table already exists, it gets overwritten. Finally, we run a simple query to fetch the first 5 rows of the table. This allows us to verify that the data has been successfully loaded into the database. Finally, we view our data preview so that there is a final summary of what we have done. And to sum up, we extracted raw sales data, We transform the data and we load the process data in the SQLite database. Over to the next section.
Thank you all. As the final speaker today, I'll tie everything together by discussing the critical role of data warehousing in enterprise app analytics, focusing on its capabilities, modern trends, and real world applications. Let's start by recognizing what a warehouse truly represents. A central repository that organizes and stores massive amounts of data from different sources. This consolidation is invaluable because it allows business to make sense of their data and use it effectively. With the help of tools like Tableau and Power BI, organizations can visualize trends, monitor performance, and generate actionable insights quickly and accurately. This centralized approach eliminates silos, ensures data integrity, and accelerates decision making. Instead of wasting time reconciling fragmented information, business can focus on strategies and solutions that drive results. Whether it's improving sales performance, optimizing supply chains or organizing supply chains or enhancing customer experiences, have a single source of truth enables organizations to be more agile and confident in their decisions. Now, let's shift our attention to the evolving landscape of data warehousing. Today's platforms like AWS Redshift and Snowflake have embraced the cloud, offering unmatched scalability and flexibility. Businesses can now scale up or down based on their needs, reducing costs and making data warehousing accessible even to smaller organizations. The cloud native solutions also integrate seamlessly with big data tools like Apache Spark, enabling advanced analytics, real time processing, and even machine learning. By leveraging these capabilities, modern enterprises can move beyond descriptive analytics into predictive and prescriptive analysis, transforming their data into a true competitive advantage. But what does this look like in practice? Let's consider a few real world examples. In sales, data warehouse enable dynamic performance dashboards, helping team track and optimize revenue stream in real time. In manufacturing, predictive maintenance powered by historical data minimizes downtime and improves efficiency. In retail, customer behavior analysis informs personalized marketing campaigns and smarter inventory management. These use cases highlights the versatility and transformative power of data warehousing across industries. Whether it's enhancing operational efficiency, improving customer satisfaction, or driving innovation, the impact is undeniable. At its core, the process of extracting, transforming, and loading ETL data into a centralized warehouse is the foundation for all this. It ensures that raw, unstructured data becomes usable and reliable, empowering businesses to move faster and smarter in an increasingly competitive landscape. As we look to the future, the trend is clear. Data warehouses will continue to evolve alongside advancements in technology, driving real time analytics, deeper integrations, and enhanced scalability. They are no longer just tools, these are strategic assets. One critical aspect that often gets overlooked is the quality of the data entering into the warehouse. Poor data quality, such as duplicates, missing values, or outdated information, can significantly hinder the insights a business can gain. This is why robust ETL processes are so important. They clean, transform, and validate the data to ensure accuracy and consistency before it's stored. As the saying goes, garbage in, garbage out. A well maintained data warehouse is only as good as the data it contains. With data becoming one of the most valuable assets, security in data warehousing is paramount. Modern platforms like Snowflake and Redshift offer built in encryption, role based access, and compliance with regulations like GDPR and HIPAA. These measures ensure that sensitive business data and customer information remain protected. As cyber threats evolve, integrating AI and machine learning for anomaly detection in data warehousing is becoming a key trend. In conclusion, data warehouse is more than a technical solution. It's a business enabler. By bridging the gap between raw data and actionable insights, it empowers organizations to thrive in today's data driven world. Thank you all for your attention. Thank you.